welcome back everyone. So, again, welcome to our beautiful channel Concept Raja. Okay, so today I'm gonna cover the topic like trigonometry, mainly the trigonometry for the physics, for studying the physics. Actually, the first video was the introduction set of videos. Now we're gonna start on our journey to learn about the mathematics and physics topics for JE. So today we're gonna start about the uh, trigonometry topics for the physics. So here I'm gonna quickly cover up the all the trigonometries functions as well as their identities. And for that, here I'm not gonna I'm not going to solve the problems here. I'm just going to show the identities. So that identities and the functions will very useful on we'll do the solving problems on the physics, practical solving problem on the physics. So we're gonna refer all these identities in the physics problem. Okay, let's start with the initial I'll start from the beginning of the trigonometry. What is trigonometric functions? We know the trigonometric functions, and from there I'm gonna do the showing the identities. I'm just not it is in the being on the time constraint. I'm not gonna prove the identities, which like we can go to the book and prove the identities, but I'll show the identities. I'll make you feel very comfortable with the identities, like how you can by seeing the the now the angles you can quickly refer back to the different conversion of the trigonometric functions. Okay, so now let's start with the trigonometric function. So first thing we know, there is a three. So trigonometry is not about the if I have a triangle, okay, right angle triangle, or I have a triangle, then I can take that right. Suppose I have a right angle triangle, okay. So if this angle is theta, so we know or this angle, so this angle will be 90 minus theta, correct? Okay, so if this angle is theta, okay, then we can write sine theta is a trigonometric function. So I hope you know the very basics of the trigonometric. So I'll start from the this start from here, like sine theta. So if I'm telling that this is the opposite, correct, of the angle, like I'm telling this is the opposite of the angle, this is the base of the triangle, correct, and this is the hypotenuse of the triangle. So the trigonometric functions are defined on a right angle triangle is that sine theta is nothing but the opposite and hypotenuse by hypotenuse, correct. Cos theta is nothing but base by hypotenuse. So we can say base, or we can say at adjacent. So this is the adjacent side of the theta, correct. This is the opposite side of the theta, this is the adjacent side of the theta, and this is the hypotenuse of the this right angle triangle. Okay, suppose if I give that A, B and C, and what is tan? Is nothing but the opposite by adjacent. Okay, so these are the three main trigonometric function, okay, base trigonometric function I could say we're gonna use, and we have the the reciprocal of these functions, correct, like sine is cosec theta. This is like a reciprocal, so we can write hypotenuse by opposite. We have a sec theta, correct, reciprocal of cos theta, it is nothing but the hypotenuse by adjacent. And we have the cot theta, which is reciprocal of tan theta. This is nothing but the adjacent by opposite. Okay, so how you gonna remember? So we have already we cannot remember this, okay, in a different ways. But what I from my what I used to do to remember this ratios, because these are the ratios of the side triangle. So these functions actually what it is connecting that angle of that angle of that triangle with the ratios of the sides. So how do you remember the ratios? Like sine is opposite. So we can remember this word. So ka to a. Okay. So what it says, sine is opposite by hypotenuse. Cos is adjacent by hypotenuse. I have written base, but it is adjacent. I can write. Okay. So adjacent by hypotenuse. What is tan? It is opposite by hypotenuse. Okay. So you can remember this word, so ka to a. Correct. So is sine, S is sine theta, C is cos theta, T is tan theta. Okay. So sine is nothing but opposite by hypotenuse, cos is nothing but adjacent by hypotenuse, tan is nothing but opposite by adjacent. Okay. And if I remember these fundamental ratios, like fundamental functions, three functions, we can easily derive this. These are nothing but the reciprocal of these functions. Okay. So in this video, because this video mainly I'm making it for the physics, for the to for the physics chapter, so I'm not gonna covering like the functions, domain, range, and all that thing. Okay. But we cover the most of the identities which is needed for uh, solving the physics problems. Okay. So now let's come to the another topic here. So this is the very basic of that, the ratios, okay, of the triangle sides with their angles. So we understand like sine theta, cos theta. So we know, like, if I know the hypotenuse, okay, or if I know the opposites, okay, if I know the one of the angles, I can calculate the opposite hypotenuse, all that things. Like we're gonna use extensively all the sine theta, like cos theta of that something, uh, in the physics. Okay, obviously we'll draw the vectors. So suppose I have a vector like this, correct? So I can get a component, like now I'll get this angle theta. So what would be the component of this vector on this? So you can easily draw this light angle triangle. So from there, if this is a vector A, I can easily get it like a, and this is the some so this will be the A cos theta. Okay. So how do I get it? So cos theta is nothing but this is some x, correct? X by a, this I know, correct? X by a. If this is a right angle triangle, x by a. So what is x? Equal to a cos theta. So now you can see that through this ratio I can easily get the component of a vector, correct? Now again, if I know what is this component of this vector, so this will be a sine theta. How we get that? This by this equal to sine theta. Or similar way, like we're gonna use all this thing extensively in the physics when we get the component of a vector, or when we solve different type of problems. So we're gonna use all these ratios. Okay. Now we'll introduce one. I think people may very much aware of this. This is called unit circle. Okay. What is this unit circle? I'll draw a circle with radius r, radius 1. So this radius, wherever I draw the radius, this is 1. Okay. Now this circle, if this is the radius, okay, so this is the, I have x-axis, correct? This is the x-axis. So this will be like, this is 0, this is 1, this is minus 1, and again this is 1, this is minus 1. This is a unit circle. Okay. Why I'm doing this why I'm drawing this unit circle? So that I can represent these ratios in another way, okay, which will be useful for most of the problem solving cases. So for example, this angle is theta. Okay, I have drawn a here the radius, and this is the radius with the x-axis. This is the x-axis, correct, and this is the y-axis. So if this is the theta, if I draw this, okay, so this point, suppose this point is x comma y in the coordinate, correct? This is the first coordinate, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, in the unit circle, this point, suppose I am taking a point, this is x comma y. Okay, now we already know the trigonometric ratio sin theta, cos theta, tan theta. Based on that, now what is this? What is this? Is that means this is y, correct? This is y and this is x. This from here to here is x. This is y. Correct. Okay. Now if I write cos theta, the ratios cos theta is nothing but SOCA, correct? K C A H. A means adjacent. So theta adjacent is x, correct? So x divided by hypotenuse. What is the hypotenuse here? It is 1 because the radius is 1. So cos theta equal to x by 1. Okay. Similarly, if I write sin theta, this is nothing but the y by 1, correct? This is y and hypotenuse is 1. Sin is opposite, correct? So theta opposite is y. Okay. Now, so from here I can write x equal to cos theta, and from here I can write y equal to sin theta. So through this, what we achieve here, actually this coordinate point, correct, x and y. So I can write the x point is nothing but the cos theta and y point is nothing but the sin theta. Okay. Now if I take any points, correct, from here, like I am drawing a point here, so this point will be nothing but the cos theta comma sin theta. Like if this angle is theta, or this angle is phi now, like you will get confused, this is theta, this angle is phi. So I can write cos phi minus sin phi, or any point, like this angle is something like alpha or something. So I can write cos alpha and sin alpha. Through unit circle, we can define the coordinate of the points using the cos and sin. Pretty good. Okay. So now, why I define that? So that I can say that what is these functions, what is the angles look like what are the cos theta and sin theta. Like now I know that x is cos theta and y is sin theta. Through that I want to explain like which coordinate it will be what, correct? Now this is first coordinate, this is second coordinate, this is third, and this is fourth. Okay, here x is x or y, both is positive. Here x is negative, y is positive, correct? Like x coordinate, if I take x is negative and y is positive. Third coordinate, both x and y is negative. Fourth coordinate, correct, x is positive and y is negative. So now we can replace x and y with cos theta and sin theta, correct? So here it is, what I can say here, cos theta is positive, first coordinate, I am talking about the first coordinate. Sin theta positive, tan theta is nothing but the, see, tan theta is opposite to adjacent, it is nothing but the sin theta by cos theta. So if sin is positive, tan is, cos is positive, then tan is obviously positive. So in the first coordinate everything is positive. Now come to the second coordinate. Okay, let's okay, come to the second coordinate. In second coordinate, what is there? If you see that x is negative, that means cos theta is negative, sin theta is positive, because y coordinate is positive. So if one negative, one positive, sin by cos will be negative. So I can say in second coordinate, correct, sin is positive, cos is negative, tan is negative. So I can say only sin is theta, sin is positive. So sin function is only positive. Other two functions, cos and tan, is negative. Okay, and if you can put that reciprocal as well, correct? Like if I cos is positive, that means sec is positive on the first coordinate. Sine is positive means cosec is positive on the first coordinate. Tan is positive means cot is positive on the first coordinate. Similarly, like I can derive the in second coordinate their reciprocal as well. Now come to the third coordinate. You can apply the same topic, correct? Same logic now. Here x and y both are negative. That means sine is negative, cos is negative, so tan will be negative by negative is positive. So third coordinate I can write tan is positive. So in the first coordinate I saw all positive. Now fourth coordinate I can see that x is positive, correct? X is positive and y is negative. So in the fourth coordinate again x positive means cos positive. X positive means x is nothing but the cos. And y is negative, correct? That means sine is negative, so obviously tan will be negative and sine will be negative. So here cos theta positive, tan theta negative, sine theta negative. Okay, so now we understood this like the how the trigonometric functions will behave on the different coordinate. Why we need this coordinate, correct? What is the need of this coordinate? Okay, we'll come to that, like slowly, like why we need this coordinate. Now, so what we have done, let's summarize the things, is that if I draw the unit circle like this is suppose this is a unit circle, okay, and I have this is the x-axis and y-axis, or if I suppose I draw this, so in the first coordinate all positive, correct? We write which are the functions are positive. In second coordinate only sign positive. So how do we remember? So I can say you, like you can, one thing is that you can remember this, correct? All sign. Here third coordinate we have seen that tan positive. Fourth coordinate we have seen that cos positive, correct? So we can remember like all sine, tan, cos, correct? Like I have to remember like all sine, tan, cos. So this is for what? Like in the first coordinate, anything, any angle with like all the sine, tan, and cos will be always positive if it is lie on the first coordinate. First coordinate means the angle will vary. Angle will vary from 0 to pi by 2 or 0 to 90 degree. I can have it in the radian or I can have it in degree. So in 0 to 90, all the ratios, like all three functions are positive and they are reciprocal as well. So in this domain, this is the domain, correct? The domain of the function. In this domain, all three functions are positive. So it will always return the positive, correct? Yeah, we have some restrictions of the domains for the tan or different things, but that details about the domain and range we're gonna discuss when we cover up the mathematics topic in trigonometry. Now, in this domain, what is this domain? From pi by 2 to pi, correct? Like after pi by 2, like the domain will be greater than pi by 2 to less than equal to pi. In this domain, what is happening? sine is positive, only sine positive, other two functions are negative. So anything will come on this will convert that function as a negative. Now come to this domain, third. So this domain is from where greater than pi to less than pi by 2 to 3 pi by 2, correct, less than 3 pi by 2. So this will be pi, this is 3 pi by 2, this is 2 pi. So in this domain what is happening, tan is positive. So whenever the angle will come to this domain, correct, is this domain means anything on the pi to 3 pi by 2. Okay, so suppose if I am if I'm rounding and coming back here, so I have covered 2 pi radian. Then again if I go, so 2 pi, okay, this will be 2 pi plus pi by 2, correct, like 2 pi, like I can keep moving on this circle, whichever which the angle given is falling on whatever domain, like whatever quadrant or domain, I can identify the function based on that, the functions like sign, like whether it is positive or negative, okay, based on where it is falling. Now on the fourth coordinate, actually it is like this coordinate, correct, 3 pi by 2 to 2 pi. So in this coordinate, if I see, the only cos is positive. Clear? Okay. So the things I will remember, all, sine, tan, cos. Okay. What is the use? Like what is the use of this? Like why we are learning this? Okay. Like now you see. So why we are learning will gradually come there, but giving one a situation, like if I given a angle is pi, like 3 pi by 3, so where it will fall, it will fall on first coordinate, correct. So now if I take sine pi by 3, then I can say this will be whatever value, it will be positive. The actual value will come there, like will come later, but now we can know the sign of the function will be positive. Not only sine, like all, like sine, tan, cos, anything I take pi by 3, it will be positive because it is falling on this first coordinate. Now if I some function I having like a pi by 2 plus theta, or like something like which is falling on this coordinate, correct. So 0, so like suppose I have an angle of 120 degree, so I know how to convert that to the radian, correct. Okay, so 120 degree, how do I convert to radian? I know 2 pi radian is nothing but the 360 degree. A pi radian equal to 180 degree, correct, or like pi radian equal to 180 degree. So 180 degree equal to pi radian, so 120 degree will be pi by 180, correct, into 120, like this is how you can convert. So 2 pi by 3. So first we see that, like they given the, like calculate sine 2 pi by 3 or cos 2 pi by 3. So now 2 pi by 3 will fall on which domain? It will fall on, this is the domain of this, correct. So this domain is only sine is positive, so I can write cos is negative here. So whatever value I get, I'll put a negative sign on that value, correct. So what is the useful of this, like when you through that through the circle, why we use the unit circle, so that it will be you can easy to remember, correct. So first thing is that x axis is the cos and y axis is the sine, correct, like the x coordinate is the cos and y coordinate is the sine. And through that we have come up with that, like a watch in which domain what functions will be in which sign, like whether it will positive or it will be negative. Okay, so this is the thing, and now we're gonna we'll have a different situations, so I can solve this, like just seeing that thing, like whether it will be positive or negative. Okay, so from here let's just quickly we'll go over, like I have given, like if something falling on here, so sine 90 plus theta, Okay, generally you will remember one thing, but we'll prove it when we'll do the another identity. That time we're gonna prove it how it is working. So sine 90 plus theta. So where it will fall? 90 means I'm telling about 90 degree here. So 90 degree means 90 plus theta means it will fall in this. Okay. Theta is obviously less than 90 degree. Okay, for this case. Now sine 90 plus theta, if I say, when I say pi by 2, anything multiple with the pi by 2. Okay, any like n pi by 2, n is a natural number, and n has to be odd natural number. Okay, so sine 90 plus theta is nothing but the, when there is a 90, okay, 90, 270, correct, like odd multiple of pi by 2, correct, 1, then 3, then 5, like sine n pi by 2 plus theta, or sine n pi by 2 minus theta, correct. So n pi by 2 means what? Like if n is 1, like n is odd natural number, odd integer, sorry, not natural, odd integer. So it will be 1, 3, 5, like that. So when there is a sine pi by 2 plus theta, like there is a, n pi by 2 plus theta, or like 1, like 1, 3 pi by 2, like there is a pi by 2 existing, that time sine will become a cos. Okay, so now function will change, correct, from sine it will become a cos. Okay, now if suppose this is 1 pi by 2, correct, 1 pi by 2 means where sine function will fall, sine will fall in the second coordinate. If suppose n equal to 1, so sine will fall on the second, that function, that domain will fall on the second coordinate. Sine will become cos, because that is the rule, like when I am doing like a odd multiple of the pi by 2, that time I am getting sine will become a cos. But if I have n equal to 1, correct, it will fall on second coordinate. Sine is positive on the second coordinate, we know, correct, all sine, tan, cos. So sine is becoming cos, and positive will be, because it will be positive sine, it will not a negative cos, correct. So sine pi by 2 plus theta will be sine theta. So the what is the the summary of this is that what I am saying here, so that we'll gonna learn like whether why what multiple is going to raise cos theta and all that thing. But as of now, just take it, what I'm saying, just take that, like sine will become cos, cos will become sine, tan will become cot, like that. Okay, when there is a odd multiple of pi by 2. Now sine n pi by 2 plus minus theta, correct, or now let's take n equal to 3. Now when 3 pi by 2 means it will fall here, 3 pi by 2 plus theta means it will fall on the fourth coordinate, correct. When n equal to 3, sine 3 pi by 2 will fall on the fourth coordinate. It will also become cos theta, but this time it will become minus cos theta, because sine n pi by 2, sorry, sine n pi by 2 plus theta, when n equal to 3, it will fall on the fourth coordinate. At the fourth coordinate, cos is positive, not sine is positive. Sine will become cos, and the sine of the sine will become negative, because in the fourth coordinate sine function is negative. That we already discussed all that thing. Okay, so this way we can say this is the usefulness of the finding the function's sign, like which sign it will fall and what will be the sign of that. Okay, thank you very much, friends. So we're gonna continue this on the next class, where we'll show more about these trigonometric functions. Thank you, and their identities. Thanks. Please keep learning and comment me whatever if you need any topics on this. Thanks.